Good morning, everybody. Welcome to an exciting Wednesday morning at Chem 11:05 with your host, me, Dr. White. Hi, everybody. All right, this morning I emailed out, and it's also in Blackboard, and I'll show you that now. Test number 1 announcement information. On Wednesday, 3/8/23, next Wednesday, I'll be giving test number 1 online. You'll download a password protected PDF file for test number 1 from the assignment area of Blackboard, and that will be available on Tuesday, the 7th of this month. On Wednesday, the 8th, at about 12 p.m., I will send out an email to each of you with the password for that PDF file for test number 1. You'll be able to open it up. You take test number 1. I'll explain that in a little while. And you'll have until Thursday, 1 p.m. to finish test number 1 and upload your test number 1 answers as a single PDF file to the assignment area Blackboard, just like you've done your labs. And it should take you about 40 minutes. If we were face-to-face, students, I give them 50 minutes. That's how long my time is in that room. But usually students are finished in 40 minutes or less. But I'll give you up to 2 hours to take that. Now, test number 1 will cover chapters 1, 2, 3, along with appendices A2 and A4 in our textbook that I've already covered in class. Now, test number 1 has 100 points with 29 problems. Relax. It may look like a lot, but there'll be 7 multiple choice plus 29 small answer problems. I'll have 8 pages, which includes a page with the key formulas. I've shown you important information. Test number 1, I'll show you in a second again. You'll be able to download from that the periodic table also. Now, you will need a scientific calculator, and on Monday of this week, you can go back and look at the video. I showed how to do scientific notation with a scientific calculator. In my syllabus, I suggest you buy this Texas Instrument calculator. I show you how to do that in the video this last Monday. These are about $15 a piece anywhere. Target, Walmart, Staples. And I've had this a number of years and it works good. And many of my students over the years have used that. Now, this is important. I reserve the right to subtract up to 25 points. Yes, 25 points for anyone who does not follow instructions, anyone who does not upload your test number 1 answers on time as a single PDF file. You got plenty of time. From the time I send out the password, you have 25 hours to take test number 1 and upload it. You don't need that, but I'm giving it to you. And that's because you may be taking other classes, and this is a net class, and therefore you should have plenty of time. Now, the Tuesday before test on Wednesday, I'll have test number 1 PDF file and the periodic table up on Blackboard. I'd recommend the day before you download it. Now, I will be posting test number 1 scores by the following Sunday after next Wednesday by 1 p.m. or earlier, like maybe even Saturday or Friday. Let's see how my week goes on Blackboard. At that time, I'll post an announcement and also send you an email that your test number 1 scores in Blackboard. Now, since I can't hand back, here, take this. No, that doesn't work. Your graded test, what I have done, and it works quite well, I will also email each individual student, each of you, the points you receive for each problem and each part of a problem if it's a multiple part, like A, B, C, and D for test 1. Now, next Monday, or not next Monday, but the Monday after test number 1, I will go over the answers for test number 1 in our Zoom meeting. But I'll delete this. I like my special effects from the Zoom meeting YouTube video, because I don't want it floating around the internet for the rest of the time. However, I will create a private YouTube video with the answers for test number 1, and I'll send you, each of you, the URL for that video so you can see it. And a couple weeks later, I'll delete it. I will do a review of material on test number 1 on next Tuesday's Zoom meeting. All right. Now, a couple of things about taking tests in my class. 1, you can print out the PDF file right on the printout, scan it, upload it as a PDF file. If you don't have a scanner, I have files, and they'll be listed in the test number 1 assignment area, and you've seen those for the lab, that how to use your cell phone or your parents or somebody's cell phone, take pictures of your answers, and then convert it into a PDF file and upload it. If you do not have a printer, you can handwrite out the answers. You don't have to handwrite out the questions. Just have your name, question 1, number, your answer, and so on. You have a scanner, scan it, upload it as a PDF file. If you don't have a scanner, use a cell phone. Actually, my button, I think, is over here on my cell phone. I'm pretending it's a camera. But anyways, use your cell phone, take pictures of the answers on your handwritten sheet of paper or papers, and then I have the file that explains how to convert that into PDF file and upload it. All right, now, concerning my tests and test number 1 that this applies for, how do you study for it? Do the practice problems. If you can do the practice problems correctly, you're set for test number 1, and later on in the semester, any of the tests you take. The other thing is, obviously, watch the videos if you haven't been able to come to my lectures. That will help you. Now, for my golden rule of teaching, I don't do to my students what I didn't like done to me. Every one of the questions on my test, I have covered the concept in our lecture at least twice, usually a lot more. Again, every concept behind every question on my test, I have covered that concept at least twice, probably a lot more times. And the way I write the test, because I didn't like it when I was a student, even though I was the one of the students, if you ever had a teacher writes tests, almost nobody can finish it. I could finish it in math and science, English too, and other things. But my test, if you've studied and done the practice problems correctly, you should be able to finish it in less than 50 minutes, usually 40 minutes, but I'll give you a lot more time. All right, any questions on that? All right, today's game plan will be, I'm going to be going through the practice problems for Appendix A2 and A4, and then we'll go back to Chapter 4 material, which will be on Test 2, not Test 1. I always try and fit in a class like this, a couple days before the test, I finish up the material that's going to be on test, because that gives me time to go through the practice problems for the test with you before the test and do a review. And remember, next Tuesday, I'll do my world famous review for the next test, test number 1. All right, let's look at the following. Remember, this is in the practice problem answers folder of Blackboard. And these are all skills you should have. Hint, these are all skills you should have. Double hint. All right, let's look at the following. Write the following numbers in scientific notation. How do you do that? You move the decimal to the right of the first non-zero number, and if there's no decimal at the end, drop all zeros. I'm going to do that. 1, 2, 3, 4, 5. So I get 6.52, and it's times 10 to the n. When the number is greater than 1, n is positive. Moved it 5 times. Here it is. Now, if the number is less than 1, n is negative. Also, any zeros after a decimal point are not dropped. In this case, D 0.00567, move it once, twice, 3 times, I get 5.67 times 10, because it's less than 1 to the minus 3. And I just noticed I don't have an example, so let me show you one. Yep. How would you write this number in scientific notation? Here's my decimal. I'll move it to the right of the first non-zero number, 1, 2. This number is less than 1, so times 10 to the n power will be a negative number. There's a 0 at the end after the decimal point. I will not drop that. And I moved it 2 times, so it'll be minus 2. You know something? Why don't you try one? How would you write this in scientific notation? Your turn. And give me a thumbs up when you're done. Or on chat, let me know you're done. And I try and give everybody time to finish. All right, let's do this. How do you write this number in scientific notation? You move the decimal point to the right of the first non-zero number. And so move it once, twice, 3 times, 4 times. All lead zeros you drop. Now zeros after a decimal point, you keep. We moved it 1, 2, 3, 4 times. So it'd be 3.7600 times 10. We moved it 1, 2, 3, 4. This number is less than 1. So 10 to the end is -4. Now, important thing about scientific notation, this number in front is never less than 1 or 10 or greater. It's never less than 1 or 10 or greater. Now, I should have revised it, but I haven't. Skip problem number 2. I'll never ask this on a test. Skip problem number 2. Write the following number in decimal notation. Just skip it. All right, let's look at problem number 3. How many significant figures are in the following number? All non-zero numbers are significant. So there's 1, 2, 3, 4, 5. Now in B, zeros at the end with no decimal are not significant. Non-zero numbers are significant. So this has 1, 2, 3. Now zeros confined between non-zero numbers are significant. And this has 2 non-zero numbers plus a confined 0 that adds up to 3. Now in scientific notation, you ignore 10 to the minus or plus 10 to the n. You just use this number. Therefore, all non-zero numbers are significant. 1, 2, 3, 4. Lead zeros are not significant. Non-zero numbers are 1, 2, 3, 3 significant figures. And in F, zeros at the end of a number with a decimal point explicitly shown are significant. Non-zero numbers are significant. 1, 2, plus these 3 zeros, because there's a decimal at the end, are significant. Now, G, I had some fun with, hopefully you did too. All non-zero numbers are significant. 1, 2, 3. All confined zeros are significant. 4, 5. Zeros at the end with no decimal are not, which is how I got 5. Now, on this one, I've made a mistake. I should have eliminated some of these. Let's look at A. Round off the numbers to 3 significant figures. You find the significant figures you want to keep, 3 of them in this case. 1, 1, 5. Then the next one you use to round off. If that's 4 or less, you drop it. If it's 5 or more, you drop it, and the one in front you increase. Now, B, C, and D, and G we won't do in this class, but E we will. Round that off to 3 significant figures. Don't count the lead zeros with a decimal there, but 3, 3, 5, those are my 3. Use 6 to round off. That's 5 or higher, I'll drop that, and the 5 I increase by 1. H, eliminate, don't do, eliminate, don't do. And why don't you try this one? Round this off. Why don't you round that number off, this one right here, to 4 significant figures? Your turn. And don't forget, if you're having problems, I'll have my office hour from 6 to 7:15 tonight on Zoom. All right. How do you round this off to 4 significant figures? Keep the first significant figure. Notice we have a decimal, so 0 is significant, this is significant, this is significant. Those are my 4 significant figures. Use this number to round off. That's 4 or less. So I'm going to drop that, everything afterward, and the answer is this. And that's how you get 4 significant figures to round off. Now, when you do mathematical operations, especially with a calculator who puts a lot of significant figures, you have to know how to round off. And for multiplication division, you get the same number of significant figures in your answer that the answer that has the number you multiply and divide that has the fewest significant figures. Now, A and B eliminate. Let's look at C. Here we multiply these two numbers, and this number is what my calculator gives me, 6.05150 times 10 to the 12. Now, if we look at the two numbers, you multiply. This has 3 significant figures. This has 3. Therefore, our answer should have 3. Keep the 6, keep the 0, keep the 5. Use the 1 to round off. That's why I have the double squiggly line. And you drop that and everything else. And that becomes 6.05 times 10 to the 12. Now, if we look at E, the first number times the second one, you get this number on your calculator. If we look at the first number here, 7.5972, that's 4 significant figures. The second number, 8.25478, has 6 significant figures. Remember, all non-zero numbers are significant. when you multiply or divide, you get the same number of significant figures in your answer as the number you multiply and divide that has the fewest significant figures. In this case, 4. So here's the number my calculator gives me. And now I have to round it off to 4 significant figures. Keep the 6, keep the 2, keep the 7, keep the 1. That's my 4 significant figures. The next number I use to round off, 3. Is that 4 or less or 5 or higher? And hopefully I'll pick 4 or less. Therefore, I drop the 3 and 2, 1, and the correct answer should be and is 6.271 times 10 to the 6. Now, for division, it's the same thing. Let's look at G. If I look at G, I'm doing a division. This is what my calculator gives me. And the top number has 3 significant figures. The bottom one has 3 significant figures. So the answer my calculator gives me, I round off to 3 significant figures. Now, how do you do that? Keep the 2, keep the 3, keep the 2. That's my 3 significant figures. And use the 3 to round off. That's 4 or less. Drop the 3, drop the 8. Here's my answer, 3 significant figures. Now, if we look at H, again, a division. For multiplication and division, you get the same number of significant figures in your answer that the number you multiply or divide by that has the fewest significant figures. 7.54678, that's a lot, has 6 significant figures. Remember, you ignore the x times 10 to the n. The bottom number you're dividing by, 4.8, 2 significant figures. Here's the answer my calculator gives me. Remember, the answer you get should have the same number of significant figures as the number you divide, in this case, or multiply, that has the fewest significant figures. Which is smaller, 2 or 6? And hopefully you pick 2. Therefore, you round this off to 2 significant figures. Keep the 1, keep the 5. Use the 7 to round off. Is that 4 or less or 5 or higher? Hopefully you pick 5 or higher. Drop that into 2 2s. The number in front, 5, I increase by 1. So it's 1.6 times 10 to the 9. Now I have some addition here. And I'm going to skip this because this will not be on test 1, but I'll teach you this when you need it for material in test 2. Any questions about problem set for Appendix A2 and A4? Well, I guess not. So let's get moving forward. And now I'm going to talk about Chapter 4 material. This will not be on test 1, but it will be on test 2 later in the semester. All right. Yesterday, I started talking about chemical bonds. And chemical bonds are the attractive forces that hold atoms together in more complex units we call molecules. And yesterday I mentioned water, H2O, which has 2 hydrogens, 1 oxygen. They're all held together by chemical bonds. Next time you look at a bottle of water, You see the H2O molecules floating around in there? Not really, but in my mind, I do. And the hydrogens and oxygen are all held together in a molecule that makes up our water by chemical bonds. Now, there are two types of chemical bonds. One is ionic bond, the other is covalent bond. Again, there are two types of chemical bonds: ionic bond, covalent bond. And it's time for Dr. White to be subtle. And you should know this. You should know this. You should know what is the definition of an ionic bond. And an ionic bond results from the transfer of one or more electrons from one atom or a group of atoms to another atom or a group of atoms. Again, you should know an ionic bond results from the transfer of one or more electrons from one atom or a group of atoms to another atom or group of atoms. And this is an ionic bond. And an example of this is sodium chloride. Sodium chloride, you know it has table salt, the white stuff you put on your French fries or other things, is made up of a sodium and a chlorine atom. And they're held together by an ionic bond. And that ionic bond was the result of a transfer of one or more electrons from one atom, like sodium, to another atom or group of atoms, like in this case, chlorine. And I'll talk more about sodium chloride. And I think I mentioned yesterday, if you go out with a bunch of chemists to a restaurant for breakfast, lunch, or dinner, one of them will always invariably say, will you please pass the NaCl, NaCl, NaCl. And I have to admit, yep, I've done it more than once. Now, time to be subtle again. Know this. What is a covalent bond? A covalent bond results from the sharing of one or more pairs of electrons between atoms. Remember, a pair means two. Pair means two. So a covalent bond results from the sharing of one or more pairs of electrons between atoms. An example of this is water. The hydrogen atoms and the oxygen are held together by sharing one or more pairs of electrons between atoms. Now, right now, I hope you're all breathing, please. And when you inhale, one of the things in air is oxygen. The other gas, O2, the other is nitrogen. I believe air is approximately 80% by weight nitrogen molecules and 20% oxygen molecules. And when you inhale, you are inhaling oxygen molecules, O2, which the two oxygen atoms are held together by covalent bonds. And that's the result of sharing of one or more pairs of electrons between atoms, the oxygen atoms. When you inhale, most of the air is nitrogen gas, N2. And the nitrogen molecule N2 results from sharing of one or more pairs of electrons between atoms, in this case, the two nitrogen atoms. Hint, know this. What does that mean? On a test, 3 points. What's an ionic bond? And you should know, and this is important, which is why I'm asking you to memorize this. Ionic bond results from the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Example of that is sodium chloride, which you should be able to do. Another one baking powder. The sodium, hydrogen, and carbon and oxygen. Well, let me do a different one. I'll leave that. Now I should do a different one because that also has a combination of both ionic and covalent. I've got one. This is calcium chloride. And that's the white little pellets you put on your sidewalk to melt ice when it's super cold. You can use sodium chloride, but when it's really cold, calcium chloride, those white pellets you buy from the big box home improvement store like Menards, Home Depot, or Lowe's, I guess you can get it other places too, that calcium and two chlorines are held together by ionic bonds. So an ionic bond results from the transfer of one or more electrons from one atom or group of atoms to another, atom or group of atoms. Now, where an ionic bond is transfer of one or more electrons, a covalent bond is sharing. And I like to put holding hands, sharing. I don't know where I came up with that, but whenever I say sharing, oh, my brain does this to make my hands do this. So when it results from the sharing of one or more pairs, remember, pair means two, of electrons between atoms, you have a covalent bond. And you should be able to give an example of a molecule with a covalent bonds in it. Water is one, oxygen gas is another, O2, nitrogen gas is another. What would be another one? Trying to think of a simple case. Well, if you drink ethanol, then the ethanol in drinks, not that I'm suggesting you ever drink, is also a molecule with only covalent bonds. Now, switches off in the sense I'll never ask what is the octet rule, but it's something you should understand. The octet rule in both ionic and covalent compounds atoms tend to acquire electron configuration of the nearest noble gas. Atoms tend to acquire the electron configuration, the same number of electrons as the nearest noble gas. If you look at the periodic table, remember when we talk about noble gases, we're talking about the elements in column 8, the last column, all the way on the right. So atoms want to get the same number of electrons, and that's because the valence electrons are full, 8, and that's most stable. I think I mentioned this story until about 1995. Let's find out. I don't know if I can or not, but let's take a look. Well, he won the Nobel Prize, Dr. William Ramsey, and no, that's not the right date. I can't find it. I'll have to find it, talk to you on Monday about it. But these used to be called the inert because they don't react. They're very stable. They're called noble gases, and they're still almost don't react. And the key thing is almost. But when an atom has the same number of electrons as the nearest noble gas, it's very stable. And in our world, atoms like to be very stable. I bet you didn't know atoms have feelings. They don't, but think of it that way. So let's take a look at this and how does it apply to chemical bonds. Now, we've already talked about valence electrons. And by the way, switches off for this. Certain arrangements are the most stable, which means they do not easily undergo spontaneous change. I don't know if they go oop, but you get the message. And the most stable is N, which is the shell number S2 N P6, 2 plus 6, 8 valence electrons, which is the number of valence electrons that the nearest noble gas has. Now, the octet rule switches off, but I want to talk about this. In compound formation, atoms of elements lose, gain, or share electrons in such a way that their electron configuration becomes identical to that of the nearest noble gases, nearest them in the periodic table. What that really means, and why this is called the octet rule, octet 8. If you've ever seen a quartet playing, string instruments are usually 4, octet 8. Think about octane number. I'll teach you that later in the semester. But that's because that means the atom has 8 valence electrons, same as the nearest noble gas. I'll never ask on a test, what is the octet rule or the final? All right, now switch is on, click, hint. You should know this. I won't ask definition, but positive ions in ionic binding or bonding that transfer one or more electrons from one atom or a group of atoms to another atom or another group of atoms causes ions. Now, when an element loses one or more, and that's the important thing, loses one or more electrons, an ion with a positive charge is formed, and that's called a cation. When an element loses one or more electrons, an ion, that means an atom with a charge, and the charge, when it loses one or more electrons, is a positive charge. And that ion with a positive charge is formed, and we call that a cation. Now, one of the skills you should have is to determine how many cations or what cation is formed from certain elements. If I look at the clock, it's time to take a break. So let's take about a 5-minute break. I can get up and stretch, and we'll be right back. So I'll be right back after our break. let's get going. We're talking about ions. And the question is, what is an ion? That's when an element loses one or more electrons And with an ion with a positive charge is formed. So let's look at magnesium. What ion can magnesium form? I have magnesium or calcium. I'm going to cheat and go back and look. Nope, magnesium. So the question is, what ion, 3 points each, does the following element form? And if you saw it sometime in the future, hint, how do you do this? Well, magnesium has this chemical symbol. And in order to do this, you have to know how many protons and electrons does magnesium have. Well, we go to our periodic table, Mg, magnesium is right here. It has how many electrons and protons? You look at the atomic number, 12. So magnesium has 12 protons, 12 electrons. Now, it wants to have the same number of electrons as the nearest noble gas. And what we mean by nearest noble gas is one nearest numerically based on the atomic number. Now, we look here, magnesium is at 12. Neon is at 10. And if we go to the end of this row, argon is 18, which is closer numerically. Neon is 2 away. Argon is 6 away. Highlight those fancy hand signals. But yeah, that was a bad joke. Sorry. But anyways, so neon is closest noble gas. So magnesium, you won't lose protons, but wants to have the same number of electrons. This case is neon, which is 10. Now we got to do some high-level math. You have 12 protons, and the charge on each proton is a +1. You have 10 electrons. The charge on an electron is -1. 12 times +1 is +12. 10 times -1 is -10. If I add them together, I get a +2. Now, how do we show that? By +2. Now, there are 2 ways of showing ions that have more than one, a +1 or -1 charge. One is plus sign, in our case 2. A newer way, which I don't like, so I don't use, but you can, is the chemical symbol to the right superscript 2 plus. I like this one better, but you can also use that one. Either one works for me on a test. Did I tell you I'm that close to the person who grades the test? Me. All right, so let's review how we did this. The question is, what ion does the following element form? And hint, you should know how to do this. For magnesium, chemical symbol Mg, because we got to go look at the periodic table, you need to know how many electrons and protons does it have. Look at the atomic number. 12. That tells you it has 12 protons and electrons. So I write that down. Abbreviate proton P, electron E. Now, magnesium wants to have the same number of electrons as the nearest noble gas. How do we do that? Well, magnesium is at 12, and numerically, what's the closest noble gas? Remember the last column with the 8 over it are your noble gases. You've got two choices, neon 10, argon 18. The difference between 10 and 12 is 2. Difference between 18 and 12 is 6. Which is smaller? Hopefully you pick 2. And therefore it wants to get the same number of electrons as neon. And that's 10, because the atomic number gives the number of protons and electrons. So that's why I have the 10 here. Now we have to do some math to find a charge. Each proton has a +1 charge. Each electron has a -1 charge. And we do the math. +1 times 12 is +12. 10 times -1 is -10. And you add it together and you get +2. And to write the ion, you show the chemical symbol plus the charge. And you can do it this way or this way. All right, let's do another one. And the question is, what ion does the following element form? And sodium, remember, has a chemical symbol Na. You should know this, like for test number 1, the symbol, not the ion form. That will be on test 2. And if we look at sodium, Na, sodium has 11 electrons and 11 protons. How do we know that? By the atomic number. And it wants to go to the nearest noble gas with the same number, with the electrons, same number of electrons as that noble gas. Now, the number of protons never change, but this is going to change. How do we find that out? We look for what's the nearest noble gas to sodium. Na, atomic number 11. Well, again, you have the same two choices, neon at 10, argon at 18. If you look at the difference between 10 and 11, the atomic number, neon, is only 1 away. The difference between the atomic number of sodium and argon is 7 away. Which is the smallest number? And hopefully pick 1. And therefore, Sodium wants to get the same number of electrons as neon, 10. And that's why I wrote this down. Now we're going to do some math. 11 protons. Each proton has a +1 charge. 10 electrons. Each electron has a -1 charge. Do the math. Plus 11 minus 10. Add them together. You get +1. Now, how do you show that? Just by that. When the number, the charge, positive or negatives is 1, you don't show the number, you just show a plus sign. If we're negative, you'd show negative. Oh, let's have you try one. I can't have all the fun. And let's try oxygen. I'll help you out. Oxygen has a chemical symbol O. Here it is on the periodic table. You have to figure out what's the nearest noble gas and do the math like I just did, and then I'll do it. Your turn. Actually, I got ahead of myself. I apologize. Let's redo this one because I haven't talked about anions. All right, instead of oxygen, my mistake, bad Dr. White. Let's do calcium instead. My mistake. What ion does calcium form? If we look at the periodic table, calcium Ca is right here. Your turn. If you're new to this and having trouble, just watch. I'll do it afterwards. All right, let's do it. Question is, what ion does calcium Ca form? Well, first of all, you have to find out how many electrons and protons does calcium have. and you look at the atomic number 20. So calcium has 20 protons and 20 electrons. Wants to go to calcium ion, in this case, I won't give it away yet, which ion, but the number of protons never changes, but the number of electrons do. It changes the same number of electrons as the nearest noble gas. We're at 20. We have two choices. Argon at 18, 2 away, krypton, Kr. Remember, krypton in our universe, unless I got stolen to another universe, is a clear, colorless gas, not a solid, green solid that kills Superman. But anyways, that's 36, which means it's 16 away, which is closer, 2 or 16. And hopefully all pick 16. So calcium wants to have the same number of electrons as argon, 18. Remember, the atomic number gives you the number of, electrons and protons. Oops, that's an electron. And now each electron has each proton has a +1 charge. Each electron has a -1 charge. Do the math, plus 20, minus 18, multiply this times this. That's how I got that. Add them together, and I get a +2. Therefore, the answer is calcium forms a +2 cation, and you could have written it this way, which I don't like to do, but you can. Either one is correct. And that's how you figure what cation or ion a certain element will form. Now, we've been talking about cations when you get a positive ion. They're negative ions. And what's a negative ion? It's when an element gains 1 or more electrons. And it's an ion with a negative charge that is formed. And this is called an anion. Positive ions are called cations. Negative ions are called anions. I'll never ask you that on a test. All right, let's look at what ion does chlorine have form. So let's do number D or letter D for this question. What ion will the following element form, 3 points each, and it's chlorine. So chlorine has a chemical symbol, Cl, and the first thing you have to know is how many protons and electrons chlorine has. Well, how do you do that? You go to your periodic table, chlorine, and a halogen, second to last column, Cl, atomic number 17, that tells you how many protons and electrons. So chlorine has 17 protons, 17 electrons. Wants to go to a chlorine ion that still has 17 protons, but how many electrons does it have? Has the same number of electrons as the nearest noble gas. Well, chlorine's at 17, the nearest one is argon, 18, because neon is 7 away, krypton is a lot more than 7 away, and argon is only 1 away. I like those special effects. Ambidextrous stereo. But anyways, It wants to have the same number of electrons as the nearest noble gas, argon, 18. So it wants to have 18 electrons. It gains electrons some way. And I'll show you how things lose and gain electrons. If not today, next week. Probably next week. Maybe today. So, time to do some math. Each of the 17 protons, a proton plus 1 charge. Each of the electrons, 18 minus 1. Do the math. Add them up, and you get a minus 1. How do you show that? Like this. Chlorine forms a minus 1 ion and anion, and the charge is minus 1. Now we can do, or you can do, oxygen. What ion does oxygen form? I'll help you out. Oxygen has a chemical symbol of O. And here's a periodic table. Your turn. What ion does oxygen form? Remember, I give everybody time to finish. So please be patient if you're waiting. All right, let's go forward. We're trying to find what ion does oxygen, chemical symbol O, for. You need to know how many protons and electrons oxygen has. Look at the atomic number, it's 8. So oxygen has 8 protons, 8 electrons. It wants to go to an ion that will still have 8 protons, but how many electrons? Well, you have to look at what is the nearest noble gas. And here we have neon 2 away, helium, He, 6 away, and argon is 10 away. So what's the smallest? 2, 6, or 10? Hopefully I'll pick 2 electrons away. So oxygen at 8 atomic number wants to have the same number of electrons as neon, 10. Now, each proton has a +1 charge. We have 8 of them. Each of the 10 electrons has a minus charge. Do the multiplication, +8 minus 10 Add that together, you get a -2. So how do you write the ion? Or Dr. White likes this way, the older way, but you can also do this way. And that's how you determine the number of ions or what ion a element can form. Now let's talk about real life. And here's calcium. And calcium can form +2 cations. How many of you have heard you need calcium in your diet to have strong bones so you don't get osteoporosis, which at my age, I've been taking for a while because I don't drink a lot of milk, calcium supplements. So does that mean we're taking calcium, the element? No, calcium, the element, is a solid metal, like my ring. And are you going to chew on a metal? No. When they tell you you need calcium for strong bones, and I believe that, I've been taking it, so you don't get things when you get older, like Dr. White, and I don't have osteoporosis, thank God, because I've been taking calcium. That means you're taking calcium cations +2. And if you look at at the screen right now, you'll see from Wikipedia the structure of what's called calcium citrate. Whenever you're taking a calcium supplement, the majority of them are calcium citrate. Now, I'll teach you more about this right here, but if you look on the right, you'll see this molecule contains calcium +2 cations. And I'll explain later on why it's written this way, but when you take a calcium supplement to get strong bones, you're taking not calcium, the element, which is a metal, solid. You're going to break your teeth and it won't get into your body. Your body absorbs from this supplement the calcium +2 cations. Now, another thing I like to mention, calcium is a +2. And all the members in that family column have the same ion form. You know, calcium is +2, magnesium is +2. You didn't have to learn this from my class, but strontium forms a +2. Now, we learned earlier, sodium forms a +1 cation. And now you should know lithium will form a +1 cation. Oxygen, +1 cation. Going over to the halogens, you learned that chlorine, we figured out, forms a -1 anion. And therefore, fluorine, F, bromine, Br, iodine, I, the ion they form also is a -1. Isn't that cool? Yep. So let's move on. Wrong slide, wrong place. Now, we talked about ionic compounds and ionic bonds. To remind you, to form an ionic compound formation, you have electron transfer. And what that means is atoms can donate give, I like my special effects give, and other atoms can accept all of those electrons that are being transferred. When such a electron transfer occurs, positive and negative ions are formed and they attract each other. It's called Coulombic attraction. How many of you heard opposites attract? Well, if you have a plus ion and a negative ion, they're attracted together, just like a magnet and metal. Not really the same, but you get the idea. And when I think about opposites attract, my best friend, who I've known since 1965, he got married in 1978. I was standing up at his wedding. His brother was best man. I guess I was second best man. But anyways, I've been friends with Neil since then and his wife, Eileen, and they are the most opposite personalities. And they've attracted, what, they've been married almost 50 years? Boy. And yeah, sometimes they fight, but all of a sudden it's gone. But like they say, opposites attract. And that happens with ions. Now, in ionic compounds, positive and negative ions are held together by strong electrical attraction between opposite charges, and we call that an ionic bond. Now, switches off for this slide and the definitions I just told you. It's interesting, ionic compounds have high melting points, 500 to 2000 degrees C. That's roughly 1,000 to 4,000 Fahrenheit. I don't know about you, but my oven in my house doesn't go that high. Turns out ionic compounds are good conductors of electricity when molten, that means liquid, or in a solution like dissolved in water. And they consist of ionic compounds. Now, we're still in Wikipedia. I don't know if I mentioned this, but for many years now, Wikipedia, because it's been so heavily policed by organic or any PhD chemist for many years, and I have the credentials and I have asked, and they do make changes in the chemical part when I ask, have been policed so heavily. It's been years since I've seen a mistake in Wikipedia for anything chemical. Other things don't know about. Chemical, it's good. Now, if you look at sodium chloride and scroll down, on the right, you'll see properties, chemical formula, other things we'll talk about later on. But the melting point of table salt, sodium chloride, is 800.7 degrees C. That's 1,473.3 degrees Fahrenheit. Whoa, is that high? Covalent molecules are much lower. Water melts at 100 degrees C to 12 Fahrenheit, which is a lot lower. But ionic compounds have very high melting points. Now, switch is on, and you should know how to do this. And what does that mean? That means determine the formula of an ionic compound, given the ions. And the formula indicates the number and kind of ions that make up that ionic compound. Now, you should know the sum of ionic charges in a formula for any molecule, ionic molecule, is always 0. Now, the subscripts in the formula of any ion has a 0 net overall charge, and the subscripts of the formula, how many atoms of each type are in that formula, are used to obtain 0 overall coverage or charge. What did I say coverage? Charge. Again, the subscripts, the number of ions present, you just see them as the atoms in the formula, are used to obtain a 0 net charge for that molecule. So how do you write ionic formulas based on the ionic charges? It's a continuation of the concept that the subscripts of the formulas are used to obtain 0 overall net charge. So what does this all mean? I went through it a little quickly, but I did that for a reason, and you'll see that a reason now. First of all, remember, I'll never ask this on a test, but you need this knowledge to do certain problems on my test. And we're talking about now test 2. And you should know all molecules have a net, notice I wrote it big because it's that important, a net 0 charge. All molecules have a net 0 charge. So what does this mean? That all molecules have a net 0 charge. By the way, hint, know this. Double hint, know this. Triple hint, know this. All molecules have a net 0 charge. So let's look at the following, 3 points each. Write the chemical formula for the molecule with the following ions. So A, do that for sodium plus cations and chloride minus 1 anions. Well, what's the charge on this sodium? It's a +1. What's the charge on the chloride anion? -1. All molecules should have a net 0 charge. And if there are only 1 sodium and 1 chlorine, a +1 added to -1, that has to equal 0. And it does. So what this tells you is there's 1 sodium, because it's a +1, only 1 of them, and 1 chlorine. And that's why sodium chloride is written this way, and that would be the answer. And let's do the next problem. Part B, write the chemical formula for the molecule with the following ions. Calcium +2, bromine, called the bromide ion, -1. So each calcium has a +2. Each bromine has a -1. If I have one of each, does that add up to 0? No. Well, you cannot change the charge of the ion in element forms. You can't, but you can change how many you have in that molecule. If this is a +2, I need a -2. How do I get that? Multiply -1 times 2. So this would be +2. 2 times -2 is -2. Now this equals 0. Because remember, all molecules have a net 0 charge. But the question asks, write the chemical formula for the molecule with the following ions. Well, if you notice, we're only using one because we didn't change that. 1 calcium. How many bromines do we need? 2. How do we show that? Br subscript 2. So calcium bromide, 1 calcium cation, 2 bromine anions. And that's how you do this. Oh, let's have you try one. What would be the chemical formula of the molecule with lithium plus, all right, lithium plus, fluoride minus? Your turn. All right, let's do it. Now, for C, we have a molecule with a lithium +1 cation. And we have a fluorine anion -1. All molecules have a net 0 charge. Again, all molecules have a net 0 charge. And therefore, this has to equal to 0, does it? +1 adding to -1, and yes. So since we didn't have to change how many, this tells me there's 1 lithium and 1 fluorine, and the answer is this, lithium fluoride. If I look at the clock, we're almost out of time. Let me remind you, don't forget, you should have yesterday, but I'll give you till today, hand in the safety lab. Don't forget the signature forms you should get up. And also, I think everybody except one person has the safety contract uploaded. All right, next Monday, I will go through chapter 3 problem set. You should try it before I do. You want to go do good. Remember, next Wednesday online, and there's an announcement. You also got an email about how I will give test number one and information of what test number one covers. Chapters 1, 2, 3, and Appendix A2 and A4. It's in there. Next Tuesday, in our Zoom meeting, I will give our my world famous review for the next test, in this case, test number one. And don't forget, tonight from 6 to 7:15, I'll have my office hour on Zoom. If you have a question, stop by. And with that, I'll say gang gesund, goodbye, stole that from Granny and the Beverly Hillbillies, and I'll see you next Monday. Or unless you come to my office hour tonight. Gang gesund, goodbye.